Amaro.
Left class daw si Agbon sir, wala lang, guba daw yung mic.
Unsa to?
O face to face daw si Agbon sir, pero
Face
wala
to
yung mic sir, guba daw yung mic sir.
sige dayon. Si Alonso, wala pa? Amaro. Anak ka dire ron? Amaro Miles? Ano os?
Sir.
Ano os? Do you want to a face to face?
Yes, sir.
Okay. Tanan man tingalin eh. So we have to divide this into 3. Arabe. Arabe. John Mark Arabe. Wala pa. Si Bernales. Bernales. Bulingot. Bulingot. Briones.
Arabe, President.
Who was that? Arabe? Arabe?
Yes, sir. Arabe, sir.
Are you interested to join the
Yes, sir.
face-to-face class, ha?
Oo, sir.
Bernales.
Interested, sir.
Bernales. Bernales. Bulingot. Bulingot, Briones.
Really, sir.
Are you interested to join the face-to-face class?
Yes, sir.
Bungkasan.
Bungkasan, present sir.
Are you interested to join the face-to-face?
Yes sir.
For those, also indicate if you do not want, if you just want an online class, no? Cuba.
Face to face, sir.
Okay. Cuesta.
Interested, sir.
Okay. Then, Fabe.
Mo join ba face to face, sir?
Oh, sige. Putalan.
Yes sir, mo join po kog face to face sir.
Gadayan.
Yes sir, mo-join po ko sir.
Okay. Gadiane.
Yes sir, mo join na po sir. Good sir.
Galiano.
Yes sir, mo-join po ko sir. FTF.
Galoy. Hermosa.
Yes sir, mo join ko face to face sir.
Abel,
sir. Mag-join na po ko, sir.
Lagahit. Lampawog.
Join, sir.
Llorente.
Join po ko sir.
Masias.
Yes sir.
Madrigal. Maglente. Magtahas. Mongkopa. Paalan.
Yes, sir. Join ko, sir.
Padayhag. Pulinar.
Yes, sir. Face to
Pulinar.
Yes, sir. Join ka face to face.
Salatan.
Online lang, sir.
Online ra ka. Okay.
Yes, sir.
Because there are some who find it difficult no to come here. that's okay. Every class, I always have an online, even if there is a face-to-face, no? So you have an option, no? Even if you think you can join face-to-face and then you can decide to have it online, that's okay. Sumael.
Face to face, sir.
Tangkalagan.
Mo-join og face to face, sir.
Okay. Timunan.
Face to face, sir.
Villaluz. Face to face ka? Yusay.
Online ra, sir.
Online ra. Okay. So, I'm going to go back to those who I did not call, no? Alonso, are you attending face to face? Bernales. Bulingot. Sila. Dapat din. Madrigal.
Online ra, sir.
Again, Madrigal?
Online ra, sir.
Online ra ka. Okay. Maglente. Magtahas. Mangkopa. Padayhag. Wala na siya. Go to the other section. Acosta.
Online ra, sir.
Online ra ni si Acosta. Okay. Then Amorganda.
Online ra isa ako, sir.
Sige. Bartolay. Kalibat.
Online ako, sir.
Online si Bartolay, sir.
Si Bartolay online report.
Oh, sir. Guba iya mic, sir.
Okay, sige. Katadman.
Face to face, sir.
Okay. Disipulo.
Face to face, sir.
Garcia.
Online, sir.
Generoso.
Face to face, sir.
Lilang.
Face to face, sir.
Makay.
Face to face, sir.
Face to face. Okay. Manayaga.
Face to face, sir.
Miral.
Online ra, sir.
Online. Moreno. Wala pa. Postigo.
Online ra, sir.
Online. Okay. Saloma.
Face to face, sir.
Face to face. Soria. Wala pa si Soria. Valencia. Eddie. Valencia, Richmond.
Online na, sir.
Si Richmond ni.
Yes, sir. Richmond.
Si Valencia, Eddie, wala. Kaya I would just like to... Okay. So, I'm going to count how many who are interested to have their class face-to-face And then I will divide you into probably 3 groups because the classroom is only very small. So you will rotate, no? You will rotate. Probably if we can have a class in 1 week, 3
Sir, excuse me,
times.
sir.
Yes.
Si Galoy, sir. Online daw siya, sir.
Daloy,
Hmm.
section.
Una
Galoy.
nga section, sir. Wala siya pa.
Galoy. Galoy, is
Oo,
that
sir.
correct?
Online.
Okay.
Yes, sir. Online.
Okay. So, again, that is what we will happen, no? So, one group will come here, the next class. It may not be always MWF or TTH because sometimes I cannot come. No, there are cases na I have to go to MC1. So, basta kay pasunod na siya, no? O first group ron, sunod na po second group, sunod po third group, ana, no? So, I'm always online, no? If this is your schedule and then probably you decide nga online, wala na problema. Ana ra. Okay, I'm going to again go over the list. Si Bernales, wala pa si Bernales? Si Bulingot. Bulingot. Maglente. Magtahas. Mungkopa. Padayhag. Moreno.
Online lang, sir.
Online ka, Moreno. By the way, this only pertains to our lecture, huh? The exam, you have no option, no? For the exam, it is always face-to-face. We'll have our exam here. Then, Surya. Valencia, Eddie.
Sir, online lang sa Sorya, sir.
Surya online. Okay.
Okay, wala pa ko nakita ang boarding house po, sir.
Oh, sige, okay. Valencia, Eddie, wala. Okay, so I'm going to repeat. The names that I will be calling are the persons who indicated that they will be online, no? Si Galoy, Madrigal, Salatan, Yusay.
What's your craziest high school confession?
Acosta, Amorganda, Bartolay, Talibat, Garcia,
High school confession.
Miral,
How many? Just
Moreno,
was it good?
Postigo,
Once or twice?
Surya.
Ever getting your ass?
Walay kuan, walay problema. Did I miss
Sir.
somebody? Again?
Valencia, sir. Is face-to-face.
Valencia, Eddie?
Yes, sir.
Face to face. Okay. So those who did not indicate are the following. Probably they are not around yet. So si Bernales, wala pa. Bulingot, wala pa. Maglente, wala pa pod. Magtahas.
Si Bernales o Bulingot, sir, online rapod to sila.
Bernales and Bulingot. Okay. Bernales and Bulingot. So ang wala diri is Lagahit. Lagahit. Maglente. Maglente, Magtahas. Mungkopa. Padayhag. Wala. So, as of the moment, I will presume nga katong wala ni indicate are online sila, no? Okay. So before we start, can I ask you to turn on your cameras, please? So that we can document our attendance, document our class for this afternoon. So I will make a final list. No, I will post it. Huh? I will post it. The groupings. No, probably I will just so that it will be easy. I will alphabetize. No, I will alphabetize which group you belong. So I'm going to post those group numbers 1, 2, 3, and then I will also post what group will come to class, no, for the next meeting.
Excuse me, sir.
Yes. Go ahead, please.
If dili kasulod og face to face, sir, pero maka sa Gmeet, sir, okay ra, sir?
Maka-join sa
Maka-join lang sa Gmeet, sir, ba, pero ipilit niya face to face niya. Dili, nay,
Oh,
sa kada.
it doesn't matter, no? For example, your choice was face to face, but in a certain day you cannot able to come here. Then you join by online. Did I answer your question? Did I answer your question? If you indicated that you want a face-to-face, but then you're not able to come, then you join online.
Sudlay, be. Muro ka sudlay.
Excuse me, sir. Yes, sir. Excuse me, sir. Sir. Sir, ang exam, sir, face-to-face siya, sir.
Yes, walay option, no? It is compulsory. It's a face-to-face exam.
Okay, sir. Thank you, sir.
That is for all your subjects in the College of Engineering. That is for all your subjects in the College of Engineering. So, just to run through, ang wala pa naka-indicate is, so in case your schedule is, you belong to the group that you're supposed to come face to face, but you have difficulty during that day, you can of course join the online class. So there's no problem with that. What I'm just trying to do to group you is so that we will not be crowded in the classroom.
Ayun nga, excuse me, sir. Kanang kuan, sir ba? What if kanang ana nga day dili na mo day nga para mo ana diya para mo face to face, but kanang day sa mo OJT, sir ba, pwede rin mo sulod gyapon ana sa imong klase, sir?
Dili na. Kay kuan man.
Puno, sir.
Mapuno naman, mapuno na ang kuan, ang atong room.
Okay, sir. Thank you, sir.
Oh. Usually pila ang kuan ang kanang OJT? 5? Ako kung kanang I will say unsay kuan. Maigo ba ng 5 pero basi lain-lain man pud nga grupo god. In one day pila nakabuk ang mo OJT tanan? 10. So manulod sila 10 tanan. Maigo.
Pero depende ra po, sir, kaya uban nga di na mo balik pagkahapon, sir.
O mo lagi na. What if mamalik tanan din, mapuno na. I will not allow you to come in. Of course, you can if you're interested, you can always use your cellphone. Magdala ra mo cellphone adto ra mo gawas. Maglaway ra mo kinsa nasulod. But you can still do that, no? But what I'm trying to do is to limit the attendees in the class. Of course, that is part of the ruling of the university, and that is also required by IATF. Wala na? Okay na ta? So, can we start now? I'll set this aside. So, those who did not indicate, meaning probably they are not around, it means that I will not, and unless they are going to indicate later, no? It means that I assume or I presume that they are online. Can you now see the board, class? Class, can you now see the board?
Yes, sir.
Yes, sir.
Okay. So let's start, no? Good afternoon, class. At least we already have probably more attending in face-to-face, no? So at least you will have more experience in the face-to-face, no? Okay. So if you try to recall, our topic was about brittle materials, no? Brittle materials last time. And then I outlined 3 formulas which are very related. No? If you will notice that the 1 over the factor of safety. No? Specifically, I have done that so that it will be easy for you to remember. Rather than what you find in the PDF, no? Okay, yung formula niya is sometimes in a different form. But it is the same. So 1 over the factor of safety, and then you have an average component and an alternating component. For when it is at H and when it is at E, the difference is that the denominators are ultimate and endurance, and the other one is yield point. So basically, that's the difference. Now for brittle materials, 1 over the factor of safety, ratio of the ultimate in tension over K. Stress in tension plus ultimate in compression over K stress in compression. So sa brittle, bulag, no? Gibulag ang compression and tension. Okay. So just to remind you, no? By the way, to inform you in advance, the exam, the first exam will be after next week. After next week. Wednesday after next week, that will be 12, I think. Is that correct?
Say coverage, sir.
I have already mentioned that, no? From the beginning until the Moore circle. Did I mention it already?
Okay, sir. Thank you.
Okay. Oh. So we will be having the exam on the conference room, which is the third floor. Itong taas kaya nga room. Okay, so unless you have any other questions of our previous topics, we will continue, no? Now, this topic is now a very important topic in machine design because it involves shafts, which is a very, very common machine element. No? In all rotating machines, you will also find shafts. Okay. So first, what are the stresses involved when you have a shaft? One of the common is that you twist a shaft, no? There is twisting, torsion of a circular shaft. Now, just like very similar, no? Very similar to the flexure, MC over I. If you will notice, MC over I. This one is shearing stress due to torsion, which is TR over JG. TR over JG. R is for the C in that one, no? It is the radius. For example, this is your shaft, and it is being twisted. Now, these arrows indicate the direction of twist, meaning you twist it that way and you twist it this way. So if you draw a line, then you twist it, the line will be deflected, no? It will be twisted in this manner, and that is your angle of twist. So that is your angle of twist. So as you twist it that way, this is your angle of twist. You have a straight line before twisting. It will now be deflected in this direction. So, and then that is the length of your. You will also find this in the PDF file, no? That is the length of your shaft. Okay, so if you want to find the shearing stress, okay, if you want to find the shearing stress on this shaft, then this is the formula, TR over JG. So, mura ra po kag MC over I, no? Dulduol na siya sa MC over I because it is the R and the C. That is more or less has a similar meaning, no? When you use C in the MC over I, it is the distance from the neutral axis to where? To the point where you are interested to find the stress. That is also true for R. It is the distance. This time, our neutral axis for our shaft is now the center. No? It is now a vertical axis, vertical line on the center. So if you want to find the stress at a certain radius, then you use that radius. If it is on the surface, then that is your radius, TR, here, near TR over J. But if it is somewhere inside, then your R should be from the center to where that point you're interested to find the stress. So similar, huh? TR over J and MC over I. Okay, T is torque, R is the radius of that location where you want to find the stress. J is now the polar moment of inertia, and G is now the modulus of elasticity in shear. This is in shear. If you will notice, modulus of elasticity, E man to siya, no? This time it is in shear. Atong A is for normal stress to siya. G is elasticity in shear. Okay. Now, since what we will be talking about are shafts which are circular in cross-section, we only have two cases. One is a solid shaft and one is a hollow shaft. The solid shaft, pi r to the fourth over 32, or mostly what is being used, if you convert this, no, you make r into d, you will have d over 2 to the fourth, then you will get this pi d to the fourth over 32. And this is the mostly common use, no? Pi d to the fourth over 32. That is, if you will notice, ang I sa MC over I is base cube over 12, no? Base cube over 12. Okay. Now, for hollow shaft, what you do is the solid minus the whole. So this is the solid pi over 2r to the fourth minus the whole inside diameter. This is the outside diameter, and this is the inside diameter represents the whole. So you just subtract because they have the same reference, which is the neutral axis. So dito ra na nimong subtract. Also for d. Again, the most common formula being used is the d. Although, if you know this one, it really doesn't matter. No, you just change your d into r.
No.
Now, angle of twist. If you will recall, angle of twist is, or if you will try to recall, it is the deformation.
Oh.
From here.
Okay.
How many degrees your shaft is being twisted? Oh, so it is an angular deformation. So similar also to the Hooke's law. Katong what do you call that? Delta ba na siya? Yung PL over AE, if you can recall that. PL over AE. Ano? PL over AE. This is also deformation, but this is linear. So you will notice, dual na sila, parentera, no? Instead of force, you have torque, and then length po to. And then instead of linear, you have J, which is polar moment of inertia, and G. Okay, so PL over AE, TR over JG. Pura na sila. Okay. Now, you have to take care of the you have to be careful with the units. The units for angle of twist, which is phi, should be in radians. And the unit of length is L, and J and G could be in SI or English. Okay? Now, if we check, for example, the unit of this in English, your torque will be in inch-pound. Torque, no? Inch-pound. Your length in inches. Your J is inch to the fourth. And G is in PSI. Pounds per square inch. If you will look at it, you will have what? Inch squared and inch. This will be inch to the fourth. So you will cancel all the units will be cancelled. And what will happen? You don't have any unit here, dimensionless. That is one of the abilities of radians. No, munay abilidad sa radians. Angle unit of radians. Sometimes it appears, sometimes it does not appear. No? So, if you try to recall, no? Can you remember?
No.
Let's say displacement R. And this is theta. And this here. This is the length of your cord. Can you remember that? Can you remember this? What is the relationship between the length of an arc to the angle to the radius? Can you remember that? Hindi mo kadumdum? Naman sa, I think sa trigo or unsa man? Relating these three. For example, circle. What is the circumference? Circumference of the circle. It is, which one? Pi r or pi d? 2 pi r. Okay. 2 pi r. What is the angle of when you go around the circle? It is what? In radians. Okay, so this is actually your angle. So, your relationship S is equals to R theta when it is just not the whole circumference. If this is your S, this is your theta, and this is your radius. So S is equals to R theta. You did not have this? This is very important. Relationship of the length of an arc to the R theta. Now, if you look at this is a length unit. And R is also a length unit. What will happen if you compute for theta? It will be a length unit over a length unit, which will cancel. Then you will have no. So what is the unit of theta? It should be in radians. That is the ability of it sometimes disappears, it sometimes appears. Like for example, this one. If I'm going to compute for S, and I know the radius, let us say my radius is 1 foot. The unit of S is not 1 foot radians. Diba? What is the unit of S? Foot, ra. Nawala ang radians. So that is nature of this relationship. When you find a length, the radians will be lost. But if you find the theta, even if it is dimensionless, radians will appear. How about those who are online or virtual? Do you have any question? No question? Silence means yes. Silence means no question. Okay? So, that is why there is no unit here. And since it's an angle unit, then the unit should be in radians. Dimensionless man is yan. That's also true for SI, huh? SI is what? Torque is Newton. What is common to you? Newton meter or Newton millimeters? Newton meter. Because in here, we are using millimeters so that our answers in stresses will be megapascals. No, but anyway, let's just say Newton meter. Length in meter. J is meter to the fourth. And G is Newton per square meter. Correct? So, how many meters? You have 2 meters and meters to the fourth. Cancel this one, Newton to Newton. That's also true if you have pascals and megapascals, no? If you want the unit in megapascals, then you use the torque Newton meters and all the rest in Newton millimeters and all the rest units in millimeters. So what I'm trying to emphasize here is that the units are important. And you will cancel all the units. It will be dimensionless and it will be in radians. Next, power. Before we go to power, in your statics, did you discuss power? Or before that, you have a certain block being pushed at a certain distance, displacement, then what unit that you can derive out of that? No, you have a certain block, you have a certain force that is pushing it at a certain distance. Tama na siya. Like force times the distance. Dili mo kakuan?
Joe, sir.
Joules. Okay, or another, if you break down joules, it will be Newton meter. So if you have here, block, and then you have a force, and then later on it traveled here, and this is your displacement S. So force times displacement is, you are talking of joules or Newton meter, that is the unit. But what is the term for that? Work. Okay? Work. Actually, it's also synonymous to energy. But this time, since it's mechanical, we say it's work. So, force times displacement is work. The rate of doing work. Okay? You divide this by how much time it takes to do this energy. That is the rate, and that is power. Okay, so that is just to ako ra nang i-reason na kay gubot man, just to refresh our minds about how we, because right away we go to power. So you review this in your mechanics, is that correct? Mechanics? Okay? So, if you have force times distance, that is, over time, power. Okay? Now, distance per unit time is velocity. Okay? So, power is also force times velocity. F times V. Now, I'm going to go back to this one. Because this formula is applied to linear motion, di ba? Your block is being pushed in a, we call it a rectilinear motion. And then how much is the displacement, the time, and the force that is required to push in that direction. Huh? By the way, what is important there is the force and the displacement should be in the same direction. Because even if you push it that way and then you move it this way, it doesn't, it's not, it's wrong if you multiply this force times that displacement. Okay, so the relationship of energy, work, of force and displacement is that they are in the same direction. Now let's go to our application here in shafts. The problem with shafts is we are not dealing with straight line. In fact, it is rotating. So we have to convert. That's why this is important. Because this is a linear unit, but the linear displacement ng S, ang kataas-on man na siya. However, the angular displacement is theta. This is the angular displacement. This is the linear displacement S.
Listen.
So what is the relationship between S and theta? Okay.
Ay, tumaw na.
This one.
Closing.
Okay. Now, in here, what we're interested in are not just the displacement, but their velocities. So what we do is, in your differential equation, differential calculus, you differentiate this with time. So ds dt is equals to r is a constant, d theta dt. Or to make it simple, just if you know, because that is a formula which is very general. Because sometimes the force is not constant, no? So when the force is not constant, the displacement also will vary. But let's presume, just to make it simpler, that force are constant, so the displacement also will be in a uniform displacement. You divide this by time, then you now have a linear velocity is equals to angular velocity. So I will write it here. This is your S, this is your theta, and that is your R. You start with S is equals to R theta. If we divide that by time, this becomes S over time. Velocity is equals to, still R is a constant, but this one is not anymore theta because we also divide it by time. We call it angular velocity. Nakakuan man eh? Kadumdum man eh? How about acceleration? Relationship of acceleration. We divide this by time. Unsa man ang mga symbols na itong ipangsulat. A is equals to R. Unsa man ang angular acceleration. Because all of these are Greek man siya, no? Greek na siya nga letters. Theta, omega, and unsa man na? Wala mo kakuanan eh? This is alpha, no? This is also angular acceleration. So, of course, we know the units of S, V, and A. This is could be feet per second, feet per minute, or meters per second, meters per minute. And also, for V, no? So, for S, it could be meters or feet. Velocity could be in meters per second, meters per minute, or meters per hour, feet, basta per unit time. Length per unit time. This one is length per unit time squared. Meter per second squared, or feet per second squared, and so on. How about the units of our angular displacement, angular velocity, and angular acceleration? So instead of the linear unit, what we have is the angle unit. So what is the unit of angle here? What is the unit of this? Okay, so this is now in radians. This is what? Radians per unit time. It could be seconds, minutes, hours, days, whatever. And this one is radians per squared, time squared. Wala mo na sa inyong kwan? That is supposed to be already. Well, I think when this building started, I was already teaching trigonometry. I think I can remember I introduced this. Okay? This is a very important relationship. Okay. So, that leads us to this one. Because this force times velocity is a linear formula, no? So we are going to convert the velocity into angular. So V is equals to R omega. And instead of force, we use torque. No? Torque is equals to force times radius. What is the relationship between this force and this radius in terms of direction? Okay. If this is your radius, it should be perpendicular to where it is revolving around. That is your force. Of course, the velocity here is the linear. Wala na ako gibutang dire ang velocity kay masapaw na sa force. But it is supposed to be here, no? But it is as a linear velocity. Not if I'm going to curve it, you might misinterpret it as angular velocity. Omega. So the angular velocity here is omega. So instead of force, we have torque over radius from this one. So instead of force, we have torque over radius, and instead of V, we have R omega. So we cancel R, then power is equals to torque times angular velocity. Okay, example. This is easy when you have it in English or in metric or SI units. What is the unit of torque? Newton meter. Unit of radians per second. So if you as I have mentioned to you again, what will happen to the radians? It will disappear. So Newton meter per second. What is that?
Watts.
Okay, Newton meter is joules, di ba? Over time, watts. So that's the unit of power. Unit of power is torque times angular velocity. So be careful, huh? If your angular velocity is not in seconds, you have to make it into seconds so that you can convert it into watts. Okay. So okay na tani. Now, in most cases, especially in engineering, we do not mention angular velocity in terms of radians per second. Unsa may inyong makuanan kanang magkuan mo og kakusgon sa pagtuyo? RPM, no? Revolutions per minute. So we use N is by the way, this N is RPM na. Revolutions per unit time. Sorry. Because actually there are two N's here nga usay maglibog ta, no? Because this N here is RPM, revolutions per minute, no? But there is also a unit here nga para sa Newton meter man siya, no? But I have no choice because that is being used in the textbook, no? So, yes. So, again, we are going to convert our omega, which is radians per time, into revolutions per time. And the relationship is that 2 pi, there are, asa naman to? There are, wala na kung sulat dire. There are 2 pi radians per revolution. Okay? There are 2 pi radians per revolution. So, munid siya na 2 pi. Actually, what happened here is, if you multiply 2 pi to n, which is revolutions per unit time, what will happen is this will become radians per unit time. No? Because n na siya is revolutions per unit time. Times 2 pi radians per revolution, you cancel the revolutions, then you will have radians per unit time, which is omega. So, in most cases, if it is RPM, we use this 2 pi Tn. But the general, general is this one. Torque times angular velocity. Okay, let's apply this. Look at the units. 2 pi, torque, and revolutions per minute. You are going to use revolutions per minute. So, what follows here is the unit, huh? So you have 2 pi radians per revolution. Diba? It's a conversion. 2 pi radians in every revolution. Torque is in foot-pounds. This is in English. And N is revolutions per minute. What will happen is you will cancel this. And of course, the ability of the radians, it will disappear. It will become foot-pounds per minute, which is a unit of, what is foot-pounds per minute unit? Power. Work or power? What is, because you just look at the unit. What is work? So if in this case, it should only be foot-pounds. Kaya per unit time man, per minute, this is a unit of power. So, foot-pounds per minute. If these are the units, no? N is in revolutions per minute, and T is in foot-pounds, and you have 2 pi Tn. Okay? The function for this is, this one will cancel, and you will also lose the radians of foot-pounds per minute. Okay, so you have 2 pi Tn foot-pounds per minute. But, again, in mechanical terms, we do not, it's very seldom we use foot-pounds per minute. Usually, what is the unit of power that we are talking about? The most common unit of power. Aside from the SI, which is watts, kilowatts, megawatts. Okay, so HP or horsepower. So we have an equivalent. For HP, you should be familiar with this, huh? 1 HP is how many foot-pounds per minute? How about if it is foot-pounds per second?
550 na kayo to, sir.
550, okay? There are only 2. Of course, you convert that, no? You convert that 33,000, it becomes 550. Okay, so 1 horsepower is the 3,000 foot-pounds per minute, or this is 550 foot-pounds per second. The SI units, or the English, is very consistent. Okay, you have 2 pi radians, torque is in Newton meters, you cancel the revolutions, you cancel the, you will have Newton meter per minute. No, Newton meter per minute. So what is, you have to make this into seconds. So you have to divide this into 60. So it becomes what? Newton meter per minute, make it into watts. So divide that by 60. 2 pi Tn over 60 is your power in watts. Now the equivalence of horsepower and watts, unsa inyong naibawan? Ang conversion from horsepower to watts.
$746, sir.
Okay. Asa na ninyo nahibawan?
Thermodynamics.
Thermodynamics. Okay. That's also true with what I have learned when I studied electrical engineering, because in electrical engineering, the unit of power is always in watts, and then you convert it into motors, becomes horsepower. 746, 746 watts is 1 horsepower. But in the PDF file that I have given you, it is 7457. That's why I place it here. But if you place 746, that's okay for me, because that is the most common. Pero I'm just placing this because that is what you will find in your PDF file. So 1 horsepower is 0.746 kilowatts, or 0.7457 if you are going to use the PDF file that I gave you by spots, So probably the 746 is rounded off to the third. So probably spots rounded up to the fourth figure. Any question? Yes. That is talking about electric motors. That is not this one. It is the RPM of the electric motor. It's not this one. Because in electric motors, you have a rotating part and then you have a stationary part. And then once your load is heavy, muhina yung rotating part. So naa siya slip, tawag lang slip, murang mudanlog siya ba? So basically, but that is for electric motors. Any other question? Class, any other question?
No, sir.
Wala na. Okay, so we should be able to convert power in different forms, foot-pounds per minute, foot-pounds per second, watts, kilowatts, horsepower. Okay? So let's proceed with some example. Okay, so what we have here is a shaft. It is simply supported, meaning there are supports at the end. And there is a torque that is twisting the shaft. The torque is, the direction of the torque here is in that direction, while this one is in the, if I look at it from this end, it is a clockwise direction for this one. But for the other one, it is a counterclockwise. Okay? Now, it is simply supported and you have a load of 9,000 newtons on the middle. The size of this shaft, solid, we're talking here of a solid shaft. It didn't mention because you will notice there's only one diameter. Because if it's a hollow, there should also be the diameter of the hole. So it is only 50 mm diameter. The question here is, remember, if this shaft is rotating, your element will also be going around in circles. And what will happen to the stresses that it will experience? It will also be different when it is at a different position. Like for example, if your element is at A, what are the stresses involved? If I'm going to draw the element like that, it will be what? Tension in this direction. Okay, in the sides. Is that correct? Because you are going to bend this in that direction, so the lower part will, in other words, your shaft will have a stress distribution of where the top is what? This is the shaft. This is actually your A here. A na siya. What is on the top? Oh, nadali ang A na sa ilalom, no? Sorry. Is that correct? So what is on top? Your load is here. If it is going to bend that way, what is the stress on top?
Compression, sir.
Okay. Below?
Tension.
Can you see my illustrations? Those who are online.
Yes, sir.
Okay. So, going back to my question here. When it is at A, what are the stresses involved? Okay, you have a tension in the longitudinal direction, ang length sa kuan. In the direction of the length of the shaft. So if this is your A, if this is your A, then you have this. Is that all? Why? Why is there a shearing? Perpendicular sa what? How are you going to compute the shear? If you say this one, how do we compute this? This stress. So because if I ask the formula, at least it gives me an idea nga asa gikan ang inyong kuan reasoning anong inakuan. How do you compute this? Unsa man to nga kuan? What? Kato akong gidrawing ganiha nga ana. Ana, how do I compute the stresses here? Huh? Okay, so this stress here is MC over I. Okay, so we're fine with that. The next question is, are there any other stresses? And then you mentioned about sharing. So we will go back to our new topic. Let's go back to our new topic. Because of the twisting of the shaft, you will have a shearing stress. Okay. If, for example, this is your element, then you twist it in that direction, and that is your shearing. When you twist it in that direction, this is your element. However, this is not in static equilibrium. No, this is not in static equilibrium. Why? Is this complete? What is needed? When we draw the element, okay na siya? Okay, we need something here. Okay, so in other words, when there is twisting, then there is shearing. Okay, so let's look at this. We are now, our element is this one. Where is the shearing direction? This is in that direction, and this one is in this direction. So, asa man ako kan? Remember, this is the shearing stress. If I'm looking at, by the way, I'm looking at the shaft. Okay, namin sa ilalom.
Excuse me, sir. Di maklaro, sir.
Ay, sorry. Tingog din mo ha, kay I'm get so engrossed with those who are here. Okay, do you follow? Now, we are now talking about this A. After we have discussed the shearing stress because of twisting, we are now going back to A, which is an element shaft of the shaft on the surface where it is being twisted. So, in this case, when I'm drawing it this way, we are looking at the element from the bottom. Okay, di man natin makita og tanaw na sa taas. So we're looking at the element from the bottom. So meaning this side is mo ni asa man ang direction? Which one? Ana? And this one is of course that way. And then of course there should be okay? So it is here. I'm just trying to illustrate it there, but it is here. The next is, of course, this one is, which is TR over J. Okay, sorry. This is your shearing stress due to twisting, this one. And then you have your stress, tensile stress due to flexural stress, MC over I. Any question? Any question? Yes. Sorry. Naa dito. Isa. Nasayop ni. 516. Okay. Care over... Ay! Nili. Care over J ni. Sorry. Care over J ni. Sorry. Ang kani na kuan ko na mix up ko ani. PR over J ra di ay. Pares ba sa MC over I? PR over J. Sorry. Class. I'm sorry. This one. TR over J. This is the twisting shear. Wala na tong G because similar to the flexure or bending stress MC over I. TR over J. I is moment of inertia and J is polar moment of inertia. So muna sila kuan na sila doon na sila kayo. Sorry. Class. Did you get the correction?
Yes, sir.
Okay, sorry. So let's proceed with the next board. Are we going to proceed with the next board? Class?
Yes, sir.
Okay. So, as I have mentioned, it is already this one. So, this is our element at A with shearing due to twisting. Due to twisting, of course, you have it here. And then, we also have flexure, tensile and flexure. So, again, to compute it, bending or flexure stress, which is a normal stress, tensile is MC over I. Or M is, wala pa nato ni makuan. How do we get M? We cut this, or if you want your shear and moment diagram, it will look something like this. Diba? And it will look something like this. And then to compute for the moment at the midsection, you find the area of this one, which is, this is your R, and that is the length. Hindi ako isulat diretso tayo. Klarohon. So your shear and moment diagram is this one, and your okay, so you want to find the moment here for the shear and moment diagram. This is, of course, the reaction R. By the way, since this is at the midsection, then it is symmetrical. So R should be 1/2 of this one because it is being divided. In 9,000 is being carried out by 2 symmetricals on each side. Torque is already given on the problem. It is 1 million Newton millimeters. Okay? Any question? Okay, so if no question, then we'll proceed. Flexure, ground stress at the bottom is tensile. MC, C is from the neutral surface to where? To the outermost five, to A. No, where is A located? Huh? Where is A located? If you have it this way, that is your neutral axis. A should be here. So what is C? Okay, 1/2 of the diameter or radius. So diameter over 2 radius. I is naano ni previously, no? Pi d to the 4th over 64. We already have this, no? Common moment of inertia for base cube over 12 man tong sa rectangle. Pi d to the 4th over 64 tong sa kuan. No? If you can recall. So pi d to the 4th over 64. So our bending is 33.0237 megapascals. Tensile niya. So let's go to the torsional shearing stress. Torsional shearing stress, PR over J. Okay. R is 1/2 of the diameter, and J is pi d to the 4th over 32. You will notice the similarities, no? The similarities of J for circular shaft. It is pi d to the 4th over 32. For J na siya, for I, it is pi d to the 4th over 64. Oh. So, ana? Pi d to the 4th over 32, pi d to the 4th over 64. Parente rago na sila, no? But don't mix it up. So, ang J, those are moment of inertia. Ha? J is polar moment of inertia, and I is rectangular moment of inertia. Okay. So pi d to the 4th over 32, or if you are going to cancel, this becomes 16, no? 32, you bring it up, divide it by 2, 16, and D, that becomes cube, 16t over pi d cube. Okay? And it is here. We just derived it there, no? But it is here. It is here, no? 16t over pi d cube for solid circular shaft. Ato orang gikuan dere, no? We just derive this 16t over pi d cube. So, you substitute value 16, 1 million, pi, 50 cube. Did you check this? Okay na siya? Okay. So, we are now complete. Our tensile stress because of flexure, because of bending, is sigma A, which is 33.0237 megapascals, and for shearing, it is 40. Okay. That is for letter A. Next, it says here, do the same for element at B. This is the element at B. At the elevation of the shaft. What do you understand about the elevation? This is a technical term for engineering. You know? what is the elevation of the machine? Okay. It is actually the location of where your centroid of the machine, no? For example, you are going to place your pump at a certain height. You measure the centroid of that pump to the ground. That is elevation, no? It is not from the bottom or not from the top, but from the side where the centroid. So our elevation here is in the middle of the. Okay. So the next problem. So if we look at this, if you look at the A ni siya, B na dire. Do you understand my drawing? B is on the side. Question. What are the stresses involved? Wala na? Wala na ko mahinumduman? Those who are online, please contribute. What are the stresses involved? When you are now at the element is now at the elevation or at the side. So just review our stresses that we have learned. First, of course, the simple tension, simple compression. And then, what is next? Bending or flexure. Do we have a bending or flexure here? Why? Because it is at the neutral axis. So we do not have bending or flexure. So what else? Transverse shear stress. Because, remember, transverse shear stress is maximum where? At the neutral axis when it is symmetrical with the horizontal axis, di ba? Now, of course, this one is symmetrical. What is on top and the bottom are mirrors. So we know that the neutral axis also passes through the center of the cross-section. So, with that, what transverse shear stress do we expect? Is it maximum or minimum or between? So it is maximum transverse shear stress. As of the moment, because of space, I'm just going to give you the maximum transverse shear stress for a solid circular shaft, no? But if we have time, we will derive this, no? Kaya gato maning transverse shear stress is V over IB, di ba? B bar A. But for solid circular shaft, the transverse shear stress is 4/3 V over area. This is also found in your PDF file. No katong let me see. Let me check, no? Class, are you still with me? I'm going to show you where you can find it. Class?
Yes, sir.
Oh, sige. Pangitaon na.
Yes, sir.
But if we have time, we will derive that. Aron, walay trampas ba? Butuo mo. Okay. Although, si spots mo na hinaingonan eh. Chapter 2 man tingnan ito. Transverse shear stress. Ano to? More circle. Before more circle. Working. Endurance limit. Dili. Chapter 1 tingali. Page! Isa na siya. It is in chapter 1. Chapter 1. I think page... Isa mo yung page ano. Formula 29, page... Isa mo yung chapter... Page 18, I think. Chapter 1. Ito na transverse shear stress. Okay, class, I'm going to share it with you. Can you see it now, class?
Yes, sir.
Okay. It says here, for solid circular cross-section, maximum transverse shear stress is this one. But we can derive that, huh? But as of the moment, dili lang sa, no? So that we do not have enough space for our discussion. Okay na? You find this. Insan nga formula 29 man tingali. You can find this insan nga page sa kuan libro. Asa ang page ani nasa asilong. Man ako umpiti ang page. Oh, 38.
38, sir.
Yes, that's right, 38. Okay? So, I'll stop sharing. Let's go back. Okay? So, the maximum transverse shear stress for a circular cross-section at the neutral axis is 4/3 V shear over area. The next question is, what is actually the shear? Because in the first part, we only use M. Di ba? Kini is, ang formula ani is this one, VIB, V bar A. But for maximum transverse shear stress, it is this one. Kini max na siya. What is V? Now remember, we are now here. So we are in between. So what is V? So if we look at the shear diagram, what is this? 4-5. And then it goes down to 4-5. Then it goes down by how much? 9,000. So this is still 4-5. Okay, so we have that 4-5. So our transverse shear stress is now 3,000.05575 megapascals. So we have actually two shearing stress. Oh, by the way, is this the only shearing stress that is involved here? Because of torsion, because it's still being twisted. The shearing stress for this one, since the whole torque starting from the right end to the left end is the same, then of course the shearing stress all throughout those parts will be the same. In all the surfaces, because TR or R here is the surface, outside surface. So there is still one more stress, which is the twisting, which is still the same as the first one. Diba? This one. So we also have another shearing stress at B due to twisting or torsion. So actually there are two shearing stress. Okay? Now, the question here is, how do we add them together? Or what is the result of these two? Okay, the first one. The first one we already know. It is this one, no? Due to torsion. How about due to transverse? Now, what happens here is that the tendency, remember, transverse shear stress is because of the bending. Because of the bending. So what will happen here is that your shaft will bend downwards. So which side will slide to the right? Which side will slide to the right? Nigbawag niya ana. Because it will be sheared here, no? So there are two sides. Which side will? Now, if you bend, you have. There's supposed to be they are in the same length. Your bending will be this way. Diba? So where is the sliding? The top will slide where? Ano man ang bend ani? Sorry. sorry, ana ang bend, oh, ana, no? Ana, di ba? Oh. This is your, assuming that this is the shaft. It bends in what direction? That way. So where is the sliding? The top will slide in which direction? To the right. Okay? So meaning, saan naman ito akong chok? It will also slide in that direction. And of course, here. And since they are the same, so it will also be this one. So what you do is, your resultant shearing stress is made up of the transverse shear stress and the twisting shear, or shear due to twisting. Okay? So the transverse shear stress is already this one. So the total shearing stress is this. Ako rin ang i-reason na duha naman eh. Because this is the total. Isa ram na ang tahan siya diha. Okay na siya duha? Okay na siya, but the total is this one, huh? They are in the same direction. So, any question? Any question? Okay. Just a reminder, no, for your preparation on the exam, we will only use our blue book, no. So probably the most, I think that if you are really fond of scratches, probably 3 blue books is more than enough, no. So I think tag 5 pesos ang ilang kuha na. Just prepare change, no. Just prepare change for the. But that is after next week pa. I'm just reminding. And also, I do not allow cell phones. Huh? So use your...
Pila na siya, sir? Kanang blue book, sir.
Tag 5 pesos ang 3 pages, I think. 3 pages man ang kuan diha. Blue book. Saan naka-country? The blue book has... Ang 4th page is the cover. 4th page is the cover, and then there are 3 pages that you can write your solution. And then you will find out in the instructions, I have instructions in the questionnaire that you are only allowed to write on one side. Okay, if I'm going to allow you to write on the other side, maglibog na ko, asa ba ning ang saluyo, number 2 ba ni siya, niya ang number 1, kaya magsunod, magtapat man sila tanan. So, at least I can arrange them and only look at one side. So that's part of the instruction. Now, in case you write on the other side, I will only check one side, ha? I will only check one side. Kung matimingan nga akong i-checkan, may gamay kag score. Imo na. So, actually, all of these are part of taking exams, no? Especially when the exam is already very critical to your life. So this is a practice. So when you find examinations like board exam or other, apply for a job, so di na mo maratol. And there are names on its questionnaire. So you sit on the chair where you find your questionnaire. Yeah. And then I'm not going to let you also borrow calculator, ha, from your kuan, because naanay mo memory ng kuan calculator, no? So I'm not going to
Magdala may compass, sir.
it's up to you. If you want, some would just use a kanang kuan, kanang piso o 10 peso coin, kanang paglingin ba? Or if you can, as long as I can decipher your circle, it really doesn't matter, no? Because if this is a class in machine elements, if this is a class in machine elements, because I have taught machine elements before, during the time of our dean, I was teaching machine elements. Compass is very important. A compass is very important. Did you discuss gears in your machine elements? But did you draw it? But did you
Yes, sir.
draw it? By not tracing. By not tracing.
Yes, sir.
It has to be drawn according to the involute profile of a gear. And also cams. You also have to use compass. If it is accelerating or decelerating, something like that. But the gear is even more intricate. It's supposed to be more intricate. Because the profile of a gear is not just a curve, it is an involute. So, any questions? Those who are attending our class online, any questions?
None, sir.
Wala na? Okay. So, in that case, I'm going to also get another screenshot. By the way, make sure you took a screenshot. Picture mo. Make sure you take your screenshot of our boards. Okay, now how do I have to go to the first board? Class?
Yes, sir.
Kana?
Okay na, sir.
Kana. Make sure nga dili matandugan ninyo ng camera kay lisod kay iset ng camera. Okay na. So, I'm going to ask you to turn on your cameras again. Okay, turn on your cameras. Okay, so that will be all for this afternoon. Thank you for a successful lecture. For those who are here, I want somebody to volunteer to raise the board. Kanang bago, kay naka-erase naman itong uban.
Bye, sir.
Bye.
Thank you, sir.
Bye, sir.
Sige, thank you.
Thank you, sir.
Thank you, sir.